Hello guys, welcome back with me, Chow Chow 2025. Today, we're turning you into a Python face detective. Buckle up because we're diving into the fascinating world of facial recognition, marking, and comparison. No prior experience is needed, just your curiosity and coding spirit. We'll be using two powerful libraries, that is OpenCV for real-time face detection and FaceTune for identifying those faces like a pro. Imagine building apps that unlock doors with your smile, tag friends and photos automatically, or even create fun face swapping filters. We'll be using two powerful libraries, that is OpenCV and face recognition for identifying those faces like a pro. Imagine building apps that unlock doors with your smile, tag friends in photos automatically, or even create fun face swapping filters. Before we even start it, make sure you already have Python installed. In this example, I use Python 3.9. I suggest you use JupyterLab for the editor, but you could use any editor that you want. I already have video about how to install Python and JupyterLab, link in the description. Now open your JupyterLab and create an empty Python notebook. What you need to do first is to install the library that we need using pip. So create a new block and add this line: pip install OpenCV Python, pip install face recognition. Remember, unless you do this in Google Colab, you only need to this once. The next time you do this, you could simply remove this line. You could also install the library in command prompt if you wish to do so. Now that all done, let's start coding and detect those faces. Think of it like a magic eye puzzle, but way cooler. Let's import all the library that we need, like CV2, face recognition, matplotlib, pyplot, and numpy. We use CD2 for drawing purpose, face recognition for detecting and comparing face, matplotlib, pyplot for making the table, and numpy for a math calculation. Next, add a new code block. This time is to read the image that are identified and the image that we're going to compare using CV2 imRead. You could add a parameter of exact location, or you could add the name if you locate the image in the same directory of your notebook. In my example, I add the picture in the same location, so I simply put the file name. Now if you want, you could show the picture that are being read, so you feel convinced that you get the right image. We could use matplotlib, pyplot to show multiple images that are being read by CV2. We create a figure first with one row and two columns. Then we add the subplot for each cell. We show the image with figure IMShow. Also, we add title for each image and remove the axis since it's not a math graph. You notice that both picture has a strange color, that because OpenCV library uses the blue, green, red, or BGR layout instead of the conventional use of RGB or red, green, blue layout. If you want it to revert to RGB model, you need to convert its color with CDT color. Here is the example. As you could see, the picture now changing like the original. Now we have the original image, let's start comparing faces. Let's take it up a notch. Can you imagine comparing two faces to see if they belong to the same person? We'll use distance metrics to measure the similarity between faces, just like comparing fingerprints. Before we could compare, we first must detect faces on the picture. To do that, we could use face encodings. This will return a list of 128 dimensional face encodings on all the faces in this picture. We will select the first face they found by putting index 0 on the right. Now let's compare the face between first image and second image. We use face recognition compare faces. The first parameter is a list of known face encodings. The second parameter is the face encoding that you want to check, and the last parameter is the tolerance. Tolerance default value is 0.6 and it should work best for regular face. Remember that the lower the tolerance, the more strict the result is. If the image you compare is somehow blurry or using accessories that hide face, you should increase the tolerance. The result only gave you information of whether it is the same face or not according to your tolerance setting. But if you want to know how much confidence the model think that one picture looked like the other, you could use face distances. This function will compare a list of known image to image that you want to check and gave Euclidean distance for each comparison face. The distance tells you how similar the faces are. You could use this result as the baseline of tolerance. Like tolerance, the lower the number of face distance, the more similar the two faces. I simplify this by making face match percentage that use formula 1 minus face distances and multiply the result with 100. Of course, the result only show you text because we don't do any drawing here. Actually, we could finish here if we only want to compare faces. But for bonuses, I will tell you how to show the result in the pictures. First, we will create a text variable and put the value according to the result. Same face or different face. Now we'll check where is the face on those two pictures using face locations. If you have more than one face in the picture, you could change the second param into the number of face you want to check. The last param is to select the model. Hog is faster and good for CPU. CNN is slower but detect face better. You must use CUDA for this and that mean using GPU that support CUDA. Face locations will return a list of tuples of found face locations in top, right, bottom, left order. After that, we will draw a square on every face that are found using CD2 rectangle. After that, we will add to the first image of whether the face is the same or different using CD2. Put text above the rectangle. Now let's try run it for the final result. Okay, the result is quite rough, but I think it is pretty good for you to get started. You could modify the script to whatever you want. Before we close, let's try another few images and let's learn about a few weaknesses of this program that I need to share. Now go to the top and let's try another images. Click Restart the kernel and run all cell to play it top to bottom so we don't need to play each block manually. Here is an example when you have different faces. Now you already see many examples on the opening video, but here I will show you a problem that you could find. First is a picture of a woman that has accessories on their face, like hijab or glasses. Using hijab, the test results still return true, but the confidence level is almost at the limit of the tolerance. The face distance is 0.58, only 0.2 difference with the tolerance. But when using glasses and with position not looking to the front, the face distance is 0.61, over the tolerance limit by 0.1. If you want, you could simply change the tolerance to 0.65 to accommodate this, but it depends on how important the use case of the program. The next example is when you found more than one faces in the picture. You could see here that the face that being compared is the man on the right. So having a visualization is also pretty important, so you know who's being compared. The solution for this ideally is to iterate every face, but it will be for another video. For now, I'm simply going to show you which part of the code that could select the face. The first one is when you're doing face encodings. Just simply select the index of the image, in this case 1. Next, for visualization, is to select the second face. That is when I equal 2. And here are the results. Okay, now you can see that the one who's being compared is the girl. Now, you see it. I will revert back the script to check the first image. The other weakness of the face encoding is that it will not able to detect face that looking side view like more than 45 degree. It simply will not consider a face and will trigger an error. You could add error handler when the program not found any faces. Congratulations! You're now starting to become Python face detective. You've unlocked the power of face detection, marking recognition, and comparison. Remember, the possibilities are endless. Go build cool projects, experiment with different algorithms, and don't forget to share your creations. Okay, guys, I think that is for today's video. Thank you for watching. Don't forget to like, share, and comment. See you again on the next episode. And have a nice day. Don't forget to subscribe.